You're listening to the Cyberwire Network, powered by N2K.
AI is making phishing attacks faster, more convincing, and harder for people to spot, and traditional security awareness and phishing training weren't designed for this level of attack. HawksHunt helps security teams prepare employees for the attacks they face every day with personalized phishing training that adapts to each employee and reduces risky behavior over time. For IT and security leaders looking to strengthen their human layer of defense without adding more manual work, visit hawkshunt.com/cyberwire to learn more. That's HOXHUNT.com/cyberwire.
The space demand just continues to grow across the board. That is a good problem to have. It means that people are understanding the importance of space and what space can bring to the fight, and how it's changing our everyday lives. However, we need to make sure that we're making the right investments to grow the supply chain to keep up with demand. And we just don't have that right now.
Welcome, I'm Maria Varmazis, and you're listening to T-Minus Space Cyber Briefing. In this show, we examine the evolution of cybersecurity in the global and orbital infrastructure that powers, protects, and connects our lives. Hello, and thank you for joining me today. It is a truth universally acknowledged, with apologies to Jane Austen, that a single industry in possession of a good fortune must be in want of supply chain issues. But seriously, the space industry must be in a very envious position right now, right? It's a boom time, especially in the United States. But the state of the space supply chain in the U.S. is more precarious than you might imagine. And considering how much risk can be introduced to organizations and missions through their supply chains, yes, InfoSec friends, this macroeconomic story is indeed for you. So to walk us through it all today, I'm speaking with two guests. One is a longtime T-Minus friend of the show, and that would be Steve Jordan Tomaszewski, Vice President for Space Systems at the Aerospace Industries Association. And my second guest is Doug Anderson, PwC Principal Partner. Now, let's dive in with Doug telling us more about himself and his expertise.
Well, I'm a partner in PwC's operations and supply chain practice. So what does that mean? I help my clients with their supply chain challenges. I've been doing that work for 20 years. And prior to that, I was an engineer. So I did a lot of technical work that helps me understand the technical things going into the supply chain, not just the business side of it. So that's what I do.
Thanks so much, Doug. And Steve, friend of the show, I hate asking you to do it yet again and hit your help, but why don't we just go for it, Steve? Tell us about yourself for the third time.
Maria, thanks very much for the opportunity to come back on the show. Always a pleasure. So I'm Steve Jordan Tomaszewski. I'm the Vice President for Space Systems at the Aerospace Industries Association. My background is really focused on national security space, kind of doing intelligence analysis, budget strategy, oversight. And now I get to represent nearly 300 companies across the aerospace and defense industry, and a lot of the manufacturers that are building the next generation of satellites and launch vehicles. Excellent. Gentlemen, thank you both for joining me today. And thank you for speaking to me about the state of our supply chain when it comes to space. So that's just sort of the general pitch, but I know there is a specific report that just came out through PwC about strengthening America's space supply chain. And Doug, I feel like this is the place where I should get the elevator pitch for what this report is, and maybe like starting super high level, what the key findings were. We'll just start there.
Sure. Yeah, I would say, the numbers kind of tell the story here. So like if you look at 2025 alone, we launched 3,700 objects into space, so satellites and other things. And that's a nearly 10x increase over the 2019 volume. But the thing is that the industrial base, all the companies that are manufacturing the goods that make up those things and all the launching and other equipment needed to get that stuff into space, that stuff barely barely grew at all. And if you look at like how old some of those facilities are, the average age of a lot of that equipment and facilities making the stuff going into space, it's like 26 years old. So we're kind of running this 2026 space economy on a 1990s infrastructure. And that gap between, this demand that's exploding and the supply that's kind of crawling along that's really why we wanted to write this report and why we felt it was urgent.
Yeah, I could absolutely imagine the urgency there. And Steve, from the industry perspective, I wanted to get your thoughts also sort of to start from a high level on that takeaway here.
So I think overall we have, as Doug mentioned, a big gap between the demand and interest in space and then actually what the supply chain and manufacturing system can actually produce. And that's a problem. So what we need to do is grow and scale the current supply chain to match all of this new incoming demand. I think one of the issues with space and supply chain has been, if you've talked to people about supply chain issues in space over the last decade or so, usually you go right into a conversation about cybersecurity and supply chain risk management and the bad guys, trying to get their hands on some, great American space technology. And that's always going to be a concern that just comes with the territory of the United States really being the prominent country in space technology overall. And we need to make sure that we're really securing our assets. However, the conversation about supply chain really needs to pivot to be more focused on how do we scale, how do we grow the overall space industrial base to keep up with all of this interesting demand.
Yeah.
And that's really what this report is about. It is about where are the current bottlenecks and challenges, and then a number of recommendations of how we can actually grow the supply chain.
Well, that feels like the natural point to say. So what what do we do about all this? Because growing with the speed that's needed to catch up, that does introduce a whole level of risk where things may be missed, especially if we're talking on the cybersecurity level. But just even taking the cyber out, the security level of things, and to say nothing of fidelity of what's moving through the supply chain. There's the thinking that you don't want to move too fast, and yet there is this urgency here, obviously. So what's to be done here? This feels almost like a catch-22 question, but what do we do? Doug, why don't I go for that one?
Yeah, well, I think one of the issues that a lot of these suppliers have is, and why are they operating on 26-year-old infrastructure, is they don't have good confidence in the demand signals going forward. And why is that? Well, a lot of that demand signal comes from the government. And what we've seen in government, budget cycles is, a lot of continuing resolutions, a lot of instability. 1 year budgets are up, 30-40%. Next year they're down. And so that instability in the demand signal tells these suppliers, boy, is it really prudent for me to make a big investment, a multi-decade investment in my facility when I'm not sure if I'm going to have demand in a few years if budgets get cut?
I think the way to fix this, there's no silver bullet here, right? So there's not just one thing that is what you can do to kind of grow the supply chain overall. Doug mentioned the demand, and that's a really key part. But our report actually outlines a couple of dozen recommendations of how you get this done. And it's a combination of looking at removing barriers to entry for new entrants and small businesses. It's looking at the current specifications and requirements, making sure that you're not over-engineering certain space-qualified parts. It's looking at labor and logistics, actually growing the workforce, and you have incentives to make it easier for folks to work in the space industry. And I think a big theme of this report is actually it needs to be the government and industry working together to solve these problems, because not only on the demand side, but of all the regulations that kind of come down to space companies, that come down to how you're even building factories and expanding manufacturing capability. It is really important for the government and industry to have a constructive dialogue and to share information about what those pain points are. Especially the faster that we can identify pain points and the earlier, then the higher likelihood we have to actually fix some of these issues.
And I would imagine for many of the components, obviously there's a lot that goes into space systems that are very exclusive for space systems, but there is some overlap, well known with other industries in general, some efficiencies I would think to be gained from that, but at the same time, that's also increased competition for those types of components. Is there any risk introduced there about maybe that crossover, or any thoughts on that, Doug?
Yeah, absolutely. I mean, this demand surge that we've seen, it's translated into this really measurable supply chain stress. And where we saw some of the break happen first was surprisingly on the electrical infrastructure side. So it's one that you maybe don't immediately think about when you think about space systems, but these are like the switch gears and transformers which you need for a launch pad or a test facility. And if you think about some of the competing demand with AI data centers and things like that, we've seen lead times for this equipment stretch to over 130 weeks or more in some cases. And just not even a year and a half ago, nothing in that space had over a year lead time. So that's a pretty stunning deterioration, increase in lead times over a short window.
Given that increased lead time, and given the competition from potentially other sectors, that it also reduces agility within the market to respond to market forces or customer demand, obviously. So it becomes a compounding problem, I would imagine. And you know what? Before we move on, let's take a quick break. When we get back, we'll take a deeper look at the specific areas of higher technical complexity in the space supply chain that are seeing the greatest supply gaps, and what kinds of risk that might introduce. More after the break.
Most environments trust far more than they should, and attackers know it. ThreatLocker solves that by enforcing default deny at the point of execution. With ThreatLocker Allow listing, you stop unknown executables cold. With ring fencing, you control how trusted applications behave. And with ThreatLocker DAC, Defense Against Configurations, you get real assurance that your environment is free of misconfigurations and clear visibility into whether you meet compliance standards. ThreatLocker is the simplest way to enforce zero-trust principles without the operational pain. It's powerful protection that gives CISOs real visibility, real control, and real peace of mind. ThreatLocker makes zero-trust attainable, even for small security teams. See why thousands of organizations choose ThreatLocker to minimize alert fatigue, stop ransomware at the source, and regain control over their environments. Schedule your demo at threatlocker.com/N2K today. When it comes to mobile application security, good enough is a risk. A recent survey shows that 72% of organizations reported at least one mobile application security incident last year, and 92% of responders reported threat levels have increased in the past 2 years. GuardSquare delivers the highest level of security for your mobile apps without compromising performance, time to market, or user experience. Discover how GuardSquare provides industry-leading security for your Android and iOS apps at www.guardsquare.com.
Welcome back. Let's get back into the conversation about space supply chain bottlenecks. Here's PwC Principal Partner Doug Anderson with more.
The report actually calls out like 9 specialized component categories that when we interviewed the AIA member companies that they consistently said had capacity gaps. So these are really components that are kind of high in technical complexity. They're Some of them are low in like commercial volume, and then there's like a high qualification burden, and this combination of forces, it drives away some of the new suppliers. New suppliers maybe look at that and go, yeah, that's not an attractive market to me. One of the suppliers that we interviewed was really walking away from the COPVs, the composite overwrap pressure vessels. These are like the fuel tanks on launch vehicles and spacecraft. Because the work associated with that consumed like over 30% of their engineering functions time, while it was only generating like low single digit contribution to their revenue. So they just said, this business it's costing us too much to operate. We're going to walk away from it. So, when the economics are that bad, you kind of can't blame them for leaving.
Yeah, no, that makes a lot of sense. Steve, I imagine you have some thoughts to this that you want to add.
Yeah, and this is what we're really excited about for this report is when we went out and talked to companies about what their current bottlenecks and challenges are. We got to this top 9 list, and I'm just going to briefly call these out for your listeners.
Please, that'd be great.
What we found out was for companies that are currently manufacturing satellites and launch vehicles, the top 9 kind of components that they cannot get their hands on right now, or there's a lot of challenges with, are optical intersatellite links, pressure vessels and propulsion tanks, rocket motor nozzles, switch gears and transformers, that electrical equipment that Doug just mentioned, connectors, field programmable gate arrays, actuators, valves, and then a category that we kind of summed up into post-processing steps. And so what happens is, because the space environment is so difficult to operate in with the vacuum of space and temperature swings and radiation environment, a lot of times if you build a certain component, you're going to have to send it to specialized post-processing facility where maybe it gets extra heat treatments or chemical treatments just to kind of help it survive in space. And one just quick example for that is that if you're looking at a connector, if you go down to your local hardware store and just buy a connector, so think of something like a USB connector at the end of a USB cord, that might cost you $7 at the hardware store. But to make something space grade, to be able to survive in space, a lot of times that same type of connector would be $529. And that is over 7,000% increase because you have to make it space qualified, extra testing, and make sure that it can survive the very challenging environment in space.
That is a fantastic example, Steve. Thank you for illustrating it with such clear numbers right there. That really drives it home. I'm hearing all this information that you both are sharing, and I'm also thinking about international geopolitical movements towards space sovereignty for certain nations, and also here in the U.S. talk about Golden Dome. And it feels hard to make these things make sense in the same context. And I'm just going, my head's spinning a little bit. I can only imagine what it's like for the supply chain right now going, we're hearing certain things in the news, for example, but the reality on the ground, it seems very different in terms of what can actually happen. How do we bridge this?
Maria, one way that I might just sum it up to your listeners is that the space demand just continues to grow across the board. That is a good problem to have. It means that people are understanding the importance of space and what space can bring to the fight, and how it's changing our everyday lives. However, we need to make sure that we're making the right investments to grow the supply chain to keep up with demand. And we just don't have that right now. But if you're looking at how America could potentially be the satellite factory of the world, and be able to meet a lot of those increased demand signals from our international allies and partners, the investments that we make today and how we're thinking about growing that supply chain will only pay dividends as long as we can kind of follow through with that, and really to make sure that we have government and industry working together to solve a lot of these problems.
the things that Steve just mentioned, some of those solutions, as well as some of the other ones that we highlight in the paper, like I can see in 5 years a major improvement in the supply chain. And the way I would look to kind of the metrics I would look at to see, have things really improved. Like I would like to see more qualified suppliers, for those critical components. Like we look at, through the supply chain, through the different components and the ones in shortage that Steve mentioned, we look at, where does that supply chain neck down to? There's only like 1 or 2 or maybe 3 qualified suppliers. I'd like to see it, much more than that. That would be one good way that we would know that there's a healthier supply chain. Move from 2 or 3 to 5 or more, and that competition will then return, and we'll also get better economics. Prices will come down. I'd like to see, secondly, like lead time reduction for long lead components. Like we talked about that electrical infrastructure and switchgear at over 130 weeks. Let's get that back under 52 weeks. Steve mentioned the post processing and testing infrastructure. Companies are waiting months and years, quarters to get their slot in that. Let's get that down into weeks. And then maybe a third one would be, like supplier bid participation rates. So as companies are, bidding out space work, let's, get the trend to be up to more like, 3, 4, 5 companies bidding on things, not, 1 or none. So I think those are some of the metrics I'd like to see as we employ some of these solutions and improve the health of the supply chain.
That makes a lot of sense. A question that's been bouncing around in my head is, I'm curious, given the many of the components that are on that top 9 list, these obviously are sounds like more high touch, more mission critical type spacecraft, for example, that these are going towards. Do commercial off-the-shelf parts make any dent in this kind of supply chain squeeze, or is that just statistically insignificant in this kind of context?
Great question, and I think there are a lot of good commercial off-the-shelf, other grade components, automotive grade, military grade, that they're not quite space grade, but if we take a risk-based approach to evaluating requirements, we can find where those components make sense. And if you think about automotive grade things, like those that standard has improved a lot over the years. And if we're just using a 1960s, Apollo era type requirement, we may not understand that those automotive grade parts are actually capable of surviving the mission these days.
I think there's examples right now that you see companies pivoting to meet some of the demands of kind of scaling up constellations. One of the things that we didn't hear about or make it to the top 9 this year was about solar panels, for example. So satellites need a lot of solar panels to provide the energy. There's been a lot of great innovation happening there, where you're not only increasing capacity for kind of the traditional space grade high efficiency solar panels, but you do have some companies are taking more risk and having new types of silicon based solar panels that might not be the same amount of traditional efficiency, but kind of getting more towards that commercial off the shelf type of approach, where they're kind of substituting things in on a case-by-case basis to kind of meet some of those mass proliferated types of requirements there. So I think the overall takeaway is we need to keep challenging the traditional specifications, requirements that we have for space systems, identify areas where maybe it's okay to take a little bit more risk, or maybe you don't need certain components and parts to be able to last, quite as long as it might have used to in the past, and make sure that's integrated all the way up and down the supply chain. And the more companies that we have that are looking at coming into the supply chain, the better the overall industrial base is going to be.
Absolutely. Well, gentlemen, I know we're coming up on time, and I want to make sure if there's anything I missed or anything that you wanted to make sure to mention to the audience, that I give you that shot. So, Doug, why don't I go to you first for closing thoughts, and then over to you, Steve?
Yeah, I just think this is a really exciting time with all the spike in demand in space. It's an exciting time to be working in supply chain, and it's an exciting time for new suppliers, new entrants, new startups, and entrepreneurs to really take a look at the space market. And don't be afraid of some of the requirements and things that are out there to enter that market. It's a fascinating, worthwhile, high growth market to be considering entering.
Excellent. Steve?
I might just wrap up by reminding your listeners that the full report about strengthening the space supply chain is available online. So if folks want to see that top 9 list we talked about, or see our dozens of recommendations of what we can do to actually improve and grow the space industrial base, it's available. And really looking forward to working with government and industry together to figure out how we can scale up manufacturing.
Well, excellent. We'll make sure to have the link in our show notes for our listeners so they can find that report and give it a read. Steve and Doug, thank you both so much for your time today and for this fantastic insight. I really appreciate it. Thanks so much for joining me today.
Thanks, Maria. Pleasure to be here.
Thank you, Maria.
And that's T-Minus Space Cyber Briefing, brought to you by N2K Cyberwire. If you like what you heard today, you will also enjoy our newsletter, Signals and Space. You'll get research and notes pulled together by our producer, Ethan Cook, and me, along with this week's top space cyber news stories. Make sure to subscribe by visiting thecyberwire.com/newsletters. We'd love to know what you think of this podcast. Your feedback ensures we deliver the insights that keep you a step ahead in the rapidly changing cybersecurity landscape. If you like our show, please share a rating and review in your podcast app. Please also fill out the survey in the show notes or send an email to space@n2k.com. We are proud that N2K Cyberwire is part of the daily routine of the most influential leaders and operators in the public and private sector, from the Fortune 500 to many of the world's preeminent intelligence and law enforcement agencies. N2K helps cybersecurity professionals grow, learn, and stay informed. As the nexus for discovery and connection, we bring you the people, the technology, and the ideas shaping the future of secure innovation. Learn how at n2k.com. Thank you for listening to T-Minus. I am your host, Maria Varmazes. The show is produced by Ethan Cook and Liz Stokes. We are mixed by Elliot Peltzman and Trey Hester, with original music by Elliot Peltzman. Our executive producer is Jennifer Iben, with content strategy by Mayan Plout. Peter Kilpie is our publisher, and we'll see you next week.
T-minus.
Ryan Reynolds here from Mint Mobile. I don't know if you knew this, but anyone can get the same premium wireless for $15 a month plan that I've been enjoying. It's not just for celebrities, so do like I did and have one of your assistants switch you to Mint Mobile today. I'm told it's super easy to do at mintmobile.com/switch.
Upfront payment of $45 for 3-month plan, equivalent to $15 per month required. Intro rate first 3 months only, then full price plan options available. Taxes and fees extra. See full terms at mintmobile.com.